Hi friends, welcome back. Till now we have studied about the standard equation of parabola. In this we are going to see more generalized form which will be more useful, and the most important topic in the parabola, that is parametric form of parabola. So this parametric form, as we will move on to the other parts, you will see the importance of parametric form, and again I'll quote that this is the most important part in the parabola. So please pay attention to it. Let's begin with the part. Let h comma k be the focus and the line lx plus my plus n be the directrix. So we want to have general equation. In the earlier part we just had the standard equation. Now we want a more general equation. So going back to the definition again, so this one we are saying that distance ps is equal to distance of p from zm, which is the directrix. So this is the general parabola. No symmetric, nothing means symmetric about obviously this axis, but again this is the most irregular shaped parabola having maximum disregularities. So from this only we are getting that the easier one. Okay, we are just keeping the vertex here, tilting the axis like that. So going by the basic definition, this is ps square, basically distance of point, and from this if you equated this, what you will get finally is this equation. So this represents a general equation of a parabola. So anytime you see an equation 2 degree, you can also make, if the 2 degree terms are making perfect square, it means that can represent a parabola. Okay, so basically that term a, b and h, 2h, x, y, if these are combining and giving something like this, then you can clearly say that is a parabola. So this equation we will see in the next part, maybe that examples we will do regarding this. So then it will be more clear how to use the general equation. So some special cases for the general equation. This is the first case. In this, instead of tilting that, what we have made, axis parallel to the x-axis. So that's the only thing. So that is similar to this, and if we have studied that concept of shifting origin, we have just moved the vertex here, and everything, if we compare it with y square equal to ax, the equation just becomes y minus beta. If this point represents alpha, beta is equal to 4a x minus alpha. This is the change which is there in this. Everything remains the same, length of the latest rectum, each other property does not change in this case. The next case will be this one, second one, and this will be axis is parallel to the y-axis, the upper one, and in this case the general equation is y x square equal to 4ay, and this one, instead of x you will have x minus alpha whole square will be equal to 4 into a y minus beta. So this you can generalize as x equal to 4, x square equal to 4ay, and where x is small x minus a, so you can find all the terms in terms of this and then substitute in the last x minus alpha and y minus beta. So this one is again very easy. So I hope that you have learned the generalized equation of the parabola, and by the end you must also have seen the importance of this form. In the next part we are going to do questions based on whatever we have done till now. Okay, so that will be a checkpoint, and stay tuned for the next part.